Good afternoon, good morning, wherever you are, folks. I'm your host, Bill Murphy. Welcome back. Thrilled to have you back. So on behalf of ASP Enterprises, Quick Supply Company, Bowman Construction Supply, and Cascade Geosynthetics, and no, Ben, I don't expect you to say all four of those every time. We're thrilled to get back to our Technical Talks webinar series. So we are kicking off a new school year. This is September. This is our first of the school year. And I invited my buddy Ben. Glad you're here. I am going to go ahead and get started. This is our Technical Talks webinar series. We're part of the Hale Holdings family of business. I'm here in Des Moines at one of our locations for Quick Supply Company. I'm wearing a Quick Supply shirt. Which hat do I have? The Bowman Construction Supply hat. I got my ASP hat. I don't currently have a Cascade hat with me, but work for all four of those companies. We're part of the Hale family of companies and been around quite a long time. As you can see, 1938. They are big in the explosives industry for mining as well. I'm not part of that. Just on our side of the company, which we call the geo or environmental, we have more than 45 years of experience through all of our offices that have been around for a long time. But this customer could be up to 15,000 beyond. The customers who purchase the products are generally contractors. What I call customers on my side are the engineers, landscape architects, city, county, state, federal government, any designers and contractors who want to learn how to put in some of these new solutions. We've got nearly 50 technical sales professionals across the map, which I'll show you. We're blessed with a lot of awesome, talented people in our warehouses and our truck drivers. We do have one civil engineer on staff. That's me. I love being asked questions. I love helping people. That's my life's goal. So here's a map of our Quick Supply location in Iowa, ASP across the Midwest, Bowman Construction Supply in the Rockies, and Cascade Geo out in the Pacific Northwest and the other half of the Rockies. So we're really thrilled to be able to have such a large area. But what that does for us, even though we're still a small family business, is it helps us be very efficient. And we learned through COVID that we were very, essential. So are a lot of you. What a blessing. And to whom much is given, much is expected. We are going to talk about a couple of products that you'll see on our website, but we carry a lot of different solutions. And we say that we're your trusted site solutions provider or supplier, and we don't take that lightly. We take it very seriously, folks. I spend most of my time helping with stormwater management, stormwater quality, green infrastructure solutions, but I also get involved with erosion control projects. If there's some roadway projects, I'm not doing the consulting, engineering, designing, and stamping plans. I am an advisor that helps any of the engineers and landscape architects we deal with, and to help communities solve problems they might have. We're blessed with some big properties, big warehouses, and it makes us very nimble. We can take very large shipments of materials and we can strategically deliver those. I call it surgically deliver those. We can get exactly what the contractor needs, where they need it. And that really matters. We're doing a downtown Denver streetscape project where they don't have room to store a lot of material. They need the product ready when the earthwork's ready and everything's got to go in the hole immediately. They're not blessed with a bunch of big open area like we are in the Midwest. So we're good at all of it. And what does that say? We're ready to deliver everything under the sun. Why would I have added that? Sun. Here's a picture I took with my wife on a walk around our property last night. So yeah, September 5th. That's how current this presentation is. And that was a sunset picture. Sun. Spanish word for sun is sol. Sol, part of the root word for solar. And what am I going to do next? Solmax. Folks, I'm very proud of this. I put that together this morning. That's my segue from that little sun image to introduce my friend, Ben Campbell from Solmax. Dr., Mr., Honorable, your Highness, Ben Campbell. Are you on, Ben?
Yes, I am, Bill. I love the segue. Thank you very much.
You bet.
That.
You sound great. I'm going to hand over controls to you.
Show some creativity for the engineers at heart, with creativity and words. All right, so I am going to drive this now. My name is Ben Campbell. I'm with Solmax. I've been there for over 6 years now, just a little over 7 now. I need to update this slide. But before that, I spent 15 years as a consulting civil engineer. I come from Clemson University, where I graduated with a BS in civil engineering. I want you all to know that we are still loyal, happy fans, even if after our devastating loss to Duke on Monday night. But yeah, so rolling on here, there's more companies we got to talk about here. Bill was touching all the ASP family companies. There's also a family of companies that's associated with us now called Solmax. You may have previously heard about Tenkata or Propex or Solmax, but we are all one company now. We're the world's largest manufacturer of geosynthetics. And you don't need to remember all these names. All you need to do is remember to contact Bill and his team when you have an issue that looks like it might be solved by something we're going to talk about here later on. So we can use geosynthetics to focus on solving issues associated with solar farms. There's a lot of renewable energies projects out there these days, and they tend to be developed in rural areas, and there's a whole variety of soil conditions associated with that, and that can bring some issues sometimes. Like what we see here. Yes, this is a big issue for construction and for maintenance and all that, but now this issue can also take place in areas where there are not solar panels. This can be anywhere, and we've got solutions that can solve this issue. Here's another example of how we have a issue at a solar farm. This is related to sedimentation and compliance of their stormwater management system, and just something that's not good when you got a bunch of bare soil and a bunch of water flowing through it, getting ready to take that soil, transport it downstream, clog up our sediment basins and our pipes and our outfalls, and then tailwaters as well. Engineering has a lot of challenges when it comes to water, not just around solar farms, but there's issues associated with channels. When water's flowing through it, it can erode the banks and end up jumping out of the channel where it shouldn't. It can also saturate soils on steepened slopes where they can start to mobilize and slip. There's many instances we try to change the slopes of these soils so that the slopes of these banks of the soils can hold themselves up, but sometimes we can't do that because there's constraints around the project that limit us in our area to be able to draw these slopes back. So the traditional solutions that we have are rock. As an engineer, I love working with rock, especially rock riprap, and then I love it when we can mix it with Portland cement and make concrete. But these are just options that are not as as feasible as they used to, and they don't really serve as well as they used to. Now that we're more concerned about solutions that can incorporate vegetation and provide all those benefits, not only in cost savings, but reduce carbon footprint, enhanced wildlife habitat, as well as enhanced stormwater quality. Concrete and rock can come in a variety of forms. It can come in just loose stones. It can come in stones that are captured in gabion baskets or wire baskets. We can turn them into blocks, and we can also form them and place them in concrete. There's a variety of things, and sometimes we need those hard armor solutions, but there are better options out there. The better solution, or another solution we can provide that could be better in many cases, is to reinforce vegetation. We reinforce vegetation with our turf reinforcement mats and our high performance turf reinforcement mats. These work to vegetation just like rebar does to concrete. Take, for instance, this channel on the right-hand side. After a storm event, we got a whole bunch of flow coming into it. That flow could bring in debris, and it could start to strip away the vegetation from the channel linings, the bottom, the sides, anywhere. And then once that vegetation is stripped away, it exposes the soil. And then the next storm event comes along and it starts to wash that soil away. And then becomes a snowball effect where before you know it, we've got all kinds of issues with sedimentation and whatnot. Use of these nature-based solutions that we call them for vegetation reinforcement can actually provide a variety of benefits that you see here. Of course, reduced cost is one of them. Next, one thing that many people don't think about a lot is how it can be used to reduce carbon footprint. In certain parts of the country, we're really concerned about carbon footprint in our projects. And although rock is pulled out of the ground, it's not as natural as you might think it is. It could, to pull the rock out of the ground takes a tremendous amount of work and effort, mechanical effort, to extract the stone out of the ground, to crush it, to transport it. And that's all good if you're in an area where you have rock that's readily available. In some cases, rock is not as available. So you can incorporate these vegetated solutions to help solve those problems and promote all these good things that you see here. These solutions have been utilized on hundreds of miles of channels, levees, coastal shorelines, as well as oversteepened slopes that are nowhere near a body of water. the products that we're talking about fall under a greater industry-wide classification called rolled erosion control products, or RECPs. And not all of them are created alike. It encapsulates a large, vast array of products that could range from straw blankets to, which are biodegradable, meant to last, anywhere from a year to 3 years, up to a high-performance turf reinforcement mat that is engineered and chemically stabilized to last, a lifetime, pretty much, and all those products in between it. It's important to note that when you're looking at a project, there's all these different products have their fit. You don't want to over design, you don't want to under design, and of course, cost always plays into it as well. The definition of turf reinforcement mat, there's many definitions. These are all ASTM standard definitions that incorporate measurements such as thickness, tensile strength, lifespan, their resistance to hydraulic stresses, non-hydraulic stresses, but essentially, turf reinforcement mats are the lower grade materials. The high performance turf reinforcement mats are the higher strength materials. They can be as strong as 3,000 pounds per foot of tensile strength, and that's what we're going to talk about mostly in the presentation today. There are needs for these other products that I mentioned, and they are generally for lower hydraulic stress situations, low debris situations, and situations where we're not looking for a lot of long-term strength. The biodegradable market, products, for instance, those biodegradable products are meant to be installed on a project where they're going to degrade after a certain amount of time. What that product does is it allows natural vegetation to root itself in, get itself in place, and then when the product degrades, the natural vegetation can hold itself together. But in situations where we have high flows or slope stability issues, that vegetation may not be able to hold itself in place for the long term. That's where we need these more permanent high performance turf reinforcement mats, or HPTRMs. At Propex, which is now part of Solmax, although we still have our same daughter brands of Propex and of the like, we have a product called Armormax 75, where we incorporated the use of installing engineered earth anchors through the mat on a slope. So this green line here illustrates what the high performance turf reinforcement mat Armormax is, with the anchors driven through. We drive these anchors anywhere from 3 to 9 feet in the ground. And what that does is it creates an artificial deep root system that holds the mat and the embankment together and resists shallow plane slope failures. And in between those anchors, we have a natural vegetation system that bridges those anchors. And then we also have a system of pinning activities that go in between the anchors as well. I can get to that in a moment here. So we combine the anchor with our TRMs to form Armormax, and we manufacture these anchors in 3 different sizes, type B1, B2, and B3. Obviously, the 1, 2, and 3 stand for the size. I have no idea what the B stands for, but anyhow, the largest anchor can resist up to 2,000 pounds of pullout. That's what we publish. We've actually been on anchor load tests where we've done tests out in the field to verify that capacity, and we've actually had some that reached 3,700 pounds. And our smallest anchor, we publish a design pullout resistance of 200 to 500 pounds. So the anchor has 3 main components. One that goes, the one is the anchor head that drives through the mat into the ground and is embedded in the ground. And at the top, at the surface, we have a top plate that sits on the surface of the mat. It has a one-way gripping device in it that allows this cable that connects the head to the top plate to be pulled out but not go back in. So essentially, it works like a post-tension concrete slab. We're putting like a post-tension situation on the anchor in the soil that's between the anchor head and the top surface plate, holding it together. So to drive them in the ground, we place a drive rod in the back of the anchor head, and then we utilize a driving mechanism. One of the most common ones is one we sell to a gasoline powered driver. It's a 4-cycle Honda engine that's mounted to a post driver that has a special fitting in it to accept the drive rod. It is driven into the ground to the predetermined engineered depth. And then once that is done, we take a product called a jack jaw, and it pulls the drive rod back out of the ground, and it also pulls tension on the cable. And when that cable is tensioned, it rotates the head from being pointed into the ground to being perpendicular to the ground. And that's what we call a load lock position, whereas there that it can hold that high amount of tensile strength. Then there's an excess amount of cable that's left over, and that cable is simply cut and discarded. We've also been very innovative as of late. We've actually started to add a fire retardant compound to our materials, and this is especially important in areas where we're concerned about wildfire or controlled burn situations, where we want to make sure that the mat is still going to maintain its integrity and not add fuel to the fire, if you will. And so that is another added benefit that we have. We have all these products. We have all these different anchor sizes. There's these rolled erosion control products of varying tensile strength. Why, how do you know which product is right for you? Well, we can take all that worry off your plate and decide that for you, of course. We have an engineering services team that is dedicated to supporting engineers and owners to help work with them through their problems and come up with a solution and select the right product that's not only going to adequately meet the engineering needs, but also meet the budget as well. We have standard details we modify all the time. We can send them to you in DWG format so you can place them into your plans. We have geotechnical engineers that perform slope stability analyses. What we do is we determine what the anchor size needs to be, how deep it needs to go in the ground, what the spacing needs to be. We also have a hydraulic analysis software, and basically allows you to analyze the channel and flows, and you can hit the design button and it'll actually give you what the proper product is. So you can perform all this. Actually, there's a link to our website where you can get in here and run this analysis yourself, or we'll be more than happy to run it for you. Let us, do the heavy lifting for you and be an extension of your resources.
I'm glad you mentioned your website, Ben. That's where I geek out, as I love this part, right, as an engineer. But we got a lot of people on this webinar, and then a lot of people that we deal with on a regular basis that they either don't know all the information for their site, so they need some help making some general assumptions, some safe assumptions, or they're just busy and don't have time to do it, or they're just uncomfortable with it. But all the above, just like you said, you have the great engineering support, and then we add value there as well. This is what separates us from a big box store where you're supposed to show up, buy whatever you think you might need, and go home and good luck. We not only train the engineers and help with the engineers on the design side, like you're talking about, but also and you'll get into this, I'm sure, the pre-construction meetings to make sure everyone knows how to properly install everything that's on the plans.
Yes,
Thanks for letting me interrupt you.
No, I appreciate the interruptions. Thank you very much. Yeah, so we also have a construction services folks that run around and help contractors, demonstrate to them how to properly install these material and how to most efficiently install the material. And you might ask yourself, well, what do we charge for all this? We actually charge nothing for any of this engineering support or construction support. We roll this into our overall product overhead, and it's just something we use to separate ourselves in the industry as someone who's going to be there to support the project from inception to completion. I'm going to talk a little bit about some case studies and some of our renewable energy experience as it relates to solar farms in particular. Here we've got a wide array of installations across the country, all the way from the temperate regions of the East, Alabama, North Carolina, South Carolina, all the way across the country into the arid regions of Arizona and California and the desert states as well.
I like to say coast to coast and border to border. You got us covered.
Yes, exactly. Yes, we do have coast to coast and border to border for sure. So first case study is going to be Alabama solar development. This was installed in 2020. There's hundreds of thousands of yards of Pyramat 50 throughout this project. It's lined in several locations. We have central drainage swales that are really shallow. And this is a picture that illustrates, what this area looked like before and then after the solar arrays came in. It's really cool, this project here. In most cases, we get called to the scene when there's an issue that's already developed, and that's what we call the reactive state. We're actually able to be included in this project on the proactive side of things during design with the engineer. And so that's why you see our materials being installed before there's any solar panels there. So the contractor went out there and did all the grading, installed our materials in these little swale areas. They also installed them on these emergency spillways for these ponds. The ponds have their outfall structures, but from time to time, it seems like we get a 500-year storm every week here nowadays. So, the design storm is kind of Now, you always want to safeguard against, a storm that could be beyond the design storm in case the spillway over top. So we got installation of those locations. And here's some more drone footage that illustrates that solar farm. You can see these areas, these low flow central drainage swales where we've got the arrays going right through it. We have ponds here with our emergency spillways armed with Armormax, and we just use our Pyramat product through these low flow central swales without any anchors. The difference between Pyramat and Armormax is really just Armormax is Pyramat with the anchors. Again, that's a lot of names and things like that. It's tough for folks to remember. Just call us and we'll recommend the right product for you. Vegetation is very important in these areas with the soil characteristics they have. So we want to make sure we're taking adequate care to make sure vegetation is established, especially on emergency spillways. You see there's a good amount of vegetation. You can see some of the mat here. This is very soon after construction was, or actually during construction while it was still going on, but we have these materials already in place to handle the stormwater flows from anything that might happen. We got some emergency spillway here and some pictures of what that looks like in a vegetated state. Eventually, the maintenance crews will come through and kind of chop that vegetation down. That's fine. The root system will still be there and continue to grow over the growing cycles. Here we have an illustration of a main drainage channel. We don't have the drainage swales that we're calling, but this is a drainage channel, a little bit deeper, narrower section, running water from one section to the next. See here, we got the mat in place. Even after some storms, it's holding itself in place. We look here, it's growing like crazy. Grass is growing really, really well through here. And like I mentioned earlier, that vegetation will be cut down by maintenance crews at some point in time, but the overall idea is to maintain a good level of vegetation over the mat here in this location. What's cool about these materials is once that's installed, they can come and drive the posts right through the mat for the solar arrays. It's very, very easy. The different designs have different style posts, different shapes of posts. They can be driven right through the mat. It's very easy to work around. However, if we are doing this in the reactive state, the material can be cut around the post as well. So that's no problem as well. The material is very resistant to loads, applied by vehicles. We got areas that are going to receive heavy vehicle traffic. The mat actually holds itself together and provides support for that. Even though the tire tracks will take the vegetation out, we still have the mat on the ground holding that soil in place. This is a picture of a skid steer with a rig on it that allows it to hold our large master roll materials. This is the material that is 15-foot wide by 480-foot long roll. We use these large rolls on large projects like this where we're covering a massive amount of area and we don't want to have a bunch of small rolls. We also manufacture them in a lot smaller rolls that can be picked up and held by 2 laborers and carried around the site and laid out. Once the mat has been rolled out onto the ground, it is then pinned in place. We drive pins every so often. You can see here, it looks like quite a bit of work for someone with a hammer. So that's why we recommend a palm driver. That this one here on this site was used. It was a air compressor powered palm driver, an air powered palm driver. They also make certain ones that are battery powered, so they're completely cordless. You don't have to have any air hoses. You can drive these pins in the ground really, really quickly versus trying to hammer them into the ground, which can be a little bit labor intensive and cause sore arms.
And some people, if no one's watching, to make sure that they'll step on them and bend them over, or if they're hammering them, they bend them over and call them good and move on. And we don't like that. So we really caution against that, and we educate proper installation.
Yes, thank you very much. Here's a solar farm in North Carolina where we were called on the reactive side of things. The arrays are already in place, and then the owner and the operator was having issues with the Department of Environmental Protection where they were not in compliant with their permit. So we got some issues here. We got some erosion coming across. We got some straw blankets that are starting to degrade away, and it just wasn't enough to support the conveyance infrastructure that we needed. Here's an example where we got a straw erosion control blanket that's failed. The water hits the solar panels, runs off into the array, into the channels, and this was just water flowing over it that was just washing it away. Straw is great for areas where we're just looking to provide a temporary cover for the grass to grow, but in areas where we're actually conveying stormwater, it's not always the best thing because it can wash away. It's got very low tensile strength and it'll ultimately biodegrade. Here's some pictures of one side where we came back with our Armormax material and placed it in the channel. We got vegetation starting to come through. We're trying to compare that to how that succeeded on the other side with just regular vegetation and straw blankets. It's performing very, very well here. They eventually decided to line up channels from side to side with the Armormax material. We do need to go back and get some more updated pictures of this. It's, you know, these projects are kind of remote in access, and access security wise is tough at times. So, but nonetheless, we've been hearing really good reports coming back from the engineer and owner on that. We're going to work our way across the country here, out into the solar zone at University of Arizona Tech Park. This was a very old installation. It's one that we're pretty proud of because we can go back to it and monitor it from time to time. It was installed in November of 2010. Soil conditions and vegetation conditions are very different out here. It's very arid and vegetation is very sparse. Soils are also drastically different. We have what you see here, a typical solar array with some channels conveying the stormwater. And you notice here, gosh, where's all our green mat? Well, it's not here. We used our tan mat here, and we have it in tan for these arid applications where we want it to blend in with the natural vegetation. We've even got some newer colors of tan and green that we're bringing out that blend in even better. And this is just kind of typical. We got our smaller width rolls here. We don't have these really, really wide rolls at this installation, but they're able to carry these rolls and roll them out and pin them in place. And this is what it looked like 9 years after construction. Looking down the channel, looks like vegetation is very, very dense, but if you look closely, there's a lot of open area here where we've got just the mat in place. And this picture here kind of shows even more of that, where yes, things do grow out in the desert, but not very much of it grows, and it doesn't really grow very far. So just there's little plantings here, not plantings, but from airborne weed seed that's taken root and grown itself together. But it's important to note here on these channel sides, you see that the mat is holding the soil beneath it in place. You know, so they have these deluge events where this channel runs full at breakneck speeds of velocity and shear, and it's holding itself together, keeping whatever plants are able to establish in place, and then still being able to shield the soil beneath it.
And Ben, this goes right back to something you said previously. You don't need to change slides, but those erosion control blankets are not meant for that kind of long-term use. And anything biodegradable would have just disappeared, and this would have been vulnerable and completely wiped out by now, especially this being 9 years old. So this is impressive. And now at this point today, it would be 13 years old if we were to go back out there. So yeah, good example.
So let's talk a minute about why these things last out in these arid conditions where they're exposed to sunlight. These products are made out of polypropylene, which is a byproduct of the refinement of petroleum. And polypropylene can degrade, but we add additives to it that stabilize it to resist exposure to sunlight. The only way that it really does degrade is if it's exposed to sunlight. The only way polypropylene degrades is if it is exposed to sunlight. So with these additives, stabilizes it and it doesn't allow it to break down. So there's a lot of concerns these days as well about microplastics and breakdowns of single-use plastics and plastic bottles. These are different plastics. These are engineered plastics that are meant to last and not break down. So sometimes people are more concerned about that. Sometimes they aren't. I have a whole bunch of information. We can talk about that offline if someone would like to hear some more information. Just some more pictures of the channel flowing through with the solar arrays on each side. And I think we might have a picture in here from, oh, nope, I guess not. So that's the end of our channels in Armormax. We got a bunch more things to talk about here. So let's look at this other solar farm. We've got some other issues associated with solar farms and other projects in general. We have really mucky soils at some instances. We saw this picture earlier. One cool thing about Solmax, including Tenkata and Propex, is we have a variety of solutions now. We bring in Tenkata as well with their high strength geosynthetics that can help reinforce roadways and reduce mucky conditions like this. There's a whole variety of products out there that can reduce, strengthen bases of roads and move along. It's important to understand that geosynthetics that are placed in like roads and embankments, they have four main characteristics of separation, filtration, confinement, and reinforcement. Sometimes we'll use like a non-woven geotextile like 140N or 160N. It's got the ability to separate different stratas of soil. It can also filtrate, but it can't really confine or provide a lot of reinforcement. There's other geogrids out there, and all these products have their place. They're all, finding their sweet spot of where they're meant on a project. But you have to understand that there's sometimes we need some of these characteristics, sometimes we need other characteristics, but Tenkata's Mirify line has a whole variety of products out there that can help meet those needs. And for more information on that and how they can, best serve your project, feel free to contact Bill or one of us. We can point you in the right direction as to what is going to be the proper geotextile to meet your project need from an engineer.
I love talking about that stuff. I've been to the Mirify plant in Georgia and walked on this in their little test pit, and walked on just GeoGrid, and I walked on a non-woven, and I walked on their RSI product, and it's amazing. So is H2RI. I'll let you keep rolling, but I love it.
Yes, yeah, that's really good stuff. We've got a lot of really good things over there in that department, and just adds to the suite of products that we can offer an overall project and provide real good benefit and value to the engineering team, to the owner themselves. Here. So we got the mucky condition that you can see all over. We got soils that are just real nasty. We need to create a haul road to get in and out of there. And by rolling out the RS380i and placing aggregate on top of it, really reinforces it, keeps that separation, keeps that stone on top, keeps that mucky soil beneath it, and provides a path for the vehicular traffic to run across. Okay. So we're going to talk a little bit about some of our shallow plane slope stabilization products here. And we're going to examine a project here that's located along a riverbank. And on the riverbank here was a chemical storage facility. And the way it worked here is a barge runs up the river, offloads all their product into this pipe bridge that then goes and fills up these tanks. And then these tanks are then piped to a terminal where they fill the trucks up, and the trucks go carry them to market to where they're needed. And the owner of the facility was getting concerned because over time they're noticing that this ridge here that drops down to the river was receding closer and closer to their fence line. And then just beyond the fence line was this pipe bridge. And if this was damaged or the foundation was damaged, it rendered the facility inoperable, and they'd have to have a tremendous repair effort to get this thing fixed. And so they were wanting to try to figure out what they could do this embankment now to armor it and prevent that from happening, prevent the shutdown and all that extra work. And you can see here they were confused because, for the most part, the river lived down low here. And it's evident by these trees that are in place. These trees are not dead. It is winter. This white stuff you see on the ground is snow. They're just leaves are gone. But if the river lived up at a higher elevation for an extended period of time, it would drown out these trees and they wouldn't be there. So they hired an engineer come out there. They considered a variety of options. They contacted someone like Bill and his team, and they referred them to us. And so they actually got a soil boring at this location, and were able to determine, that there was two main strata of soil on this river embankment. There was a sandy clay underlain by a clay sand with these representative unit weight, cohesion, and phi values. And if there's any geotechnical engineers on, they would probably enjoy this more so than some of our civil engineers like myself, but I still have to talk about it anyway. So what this is a output slide from our slope stability model where we plug all these parameters in there. We plug in the slope height, we plug in the gradient, what's going on above the slope, what's going on below the slope, and then analyze it for the shallow plane failure that we're seeing there, where it's just continuing to slough off and fail. We set the failure depth limit at 3 feet here, and out comes a number here, this red dot with 0.98. What this red dot number is, it's the factor of safety for slope stability at this location. If we go back to engineering basics, we remember that anything with a factor of safety less than 1 should be failing, anything with a factor of safety greater than 1 should be fine. We all have different goal factors of safety depending upon what we're designing for, whether it's a structural steel building or a slope. What we're trying to get to for slope stability is long-term factor of safety of 1.5. So we then go into the model, we place our anchors into the slope itself. We place our size B2, which stands for bullet size 2, and we drive them 9 feet in the ground. We place them on a 4 foot by 2.5 foot spacing. We typically place them on about a 4 foot by 4 foot spacing. We had to bring this spacing in a little bit closer because of the soil characteristics that we were dealing with. Yes, that's what we do. We analyze how deep they need to go, how close they need to be together, and then figure out, are we going to get above that long-term goal of 1.5 factor of safety? And so we did. So here we got some pictures of reconstruction of the slope, and we can see here that they're just kind of beating the bucket on the embankment here. Now this is not the preferred way of recompacting an embankment. We generally want to compact in bench lifts, but I mentioned earlier we have a construction services folks that go out into the field and help the contractor understand how to install our materials, but we don't always have control over them and how they install everything else like soil and whatnot. So I'll remember this. I'll come back to this in a minute. So what this crew did is they were pre-cutting the roll mat lengths to whatever the length was needed on this slope here. They had a little staging area off to the side, and they would cut the mat, and then one worker could carry the mat over, drop it in the trench above it, and roll it on down the slope. After that was done, several panels would be rolled down the slope. They'd come back and start pinning these materials, and these stripes in the material, they're not in there because we think that they look cool. They're in there because it helps the contractor understand what the spacing of the anchors and pins needs to be, also what the overlap spacing needs to be between different panels. So we're not getting too much overlap, we're not getting not enough overlap. After the anchors are driven, we have guys that are utilizing this device to pull tension on the cable. This brings the anchor head that's in the ground 9 feet into its load lock position, and then they will come back after this is all done and simply cut the excess cables and throw them away. This is what that looked like before they came in. Next step will be to establish vegetation. You can establish vegetation in several ways. You can utilize topsoil, you can utilize hydroseed, you can utilize sod. This project utilized topsoil and seed. So they brought their skid steer in with a bucket full of topsoil, dropped it on the crest, and then the workers could then rake the material down. We generally place about 1 to 2 inches of topsoil on top of the mat and then place the seed material on it. We then come back and we'll roll out a straw blanket. Now, I'm talking all bad about straw blankets before, but no, that they're not always bad. We always need to place something over an open excavation. And even though our Armormax is on the slope, we place topsoil on top of it. We still need to protect that topsoil, and on that slope especially, until the grass is able to germinate and able to get its root system in place. We know that this was installed in March, which is very early spring in this area. So it needed to be protected for a while so seeds wouldn't wash off and the birds wouldn't come by and eat them. And then that straw blanket would eventually degrade. So exactly 2 months later, we had a great stand of vegetation here. And the person taking the picture walks out on the barge dock and sees that there's a slough happening over here. We've got a bunch of straw. What's going on here? Well, upon closer examination, we see we got that straw blanket here, but we do not see the green Armormax material beneath it. So for whatever reason, the contractor decided to stop around about here. I hate it for everybody involved. I wish they would have just contacted us. We would have sent them another roll of material along with some extra anchors. But nonetheless, it's a good case study that shows side by side what armored looks like versus unarmored. All right. I have another product here I'm going to talk to you about called Scourlok. So Scourlok is kind of a derivative of some of the products I've already talked to you about. I've talked to you about our Armormax HPTRM. I've talked a little bit about some other geotextiles. And what Scourlok does is it is a kind of like a gabion basket. For those of you who have had experience with gabion baskets, it's a gabion basket is a wire basket that is filled with stone. I showed a picture of it earlier in my presentation. It's a good little tool to have in the toolbox for certain applications, but you don't always have to use this gabion basket system that's filled with stone. The advantage of Scourlok is that it can be filled with soil. So it is a welded wire steel cage on the outside, and it has a non-woven geotextile on the inside. Then on the outside, it has our Armormax HP TRM on it. So take this typical section here where we're looking to provide some sort of tow reinforcement at a pond bank, a river bank, a creek bank, whatnot. You can actually install Scourlok here utilizing in situ soils as fill material and becomes a green wall. Yep. This is what it looks like after it comes on a pallet. The unit is all folded up, it's fully assembled, whereas a gabion basket has to be all tied together. There's other systems out there that have a lot more labor associated with them to construct them, but you can expand this material. Each section comes in a 15-foot long segment that has 5 different cells in them. Each are 3 feet wide. And here you can see there's that welded galvanized steel cage on the outside and the non-woven on the inside. We got the HP TRM on the face of it. And after it's done being filled up, you simply take the flap and fill it over, or fold it over and cover it. This allows you to place the whatever kind of soils or in situ soils you have on site in the main part of the cell. And then there's a pocket that's formed by the HP TRM on the face. And what that does is it allows you to fill that with topsoil, or more fertile soil, at least, that could support vegetation. And then over the years, it will start to grow and become a green wall. These are all designed wall sections, just like any other mechanically stabilized earth wall or MSE wall. And here's just some pictures of what this filling activity looks like with filling topsoil. There's some other pictures over here that show some highlights of different projects we've had over the years and how they vegetate. And, they can be in areas where we have streams, where we don't have streams, anywhere we need a grade separation. Commonly I get the comment that these wall systems are not the most, are not the prettiest things in the world. They are pretty in our eyes because they vegetate, but it's not a modular concrete block wall or some decorative cast in place wall. This is meant to be a situation or a solution that can be used for situations where we're looking to have a vegetative wall and a green space and ultimately blend into the background. Here's a pipeline project, and we're looking at here. We came upon this project. A contractor contacted Bill's team at ASP and said, hey, we've got an issue here. We've got a slip of this slope here, and there's a creek down at the toe. And obviously we can see here that if this slip is able to continue, that it could ultimately plug up the creek and cause a whole bunch of issues from a flooding standpoint, as well as a sedimentation and environmental issue. So they consulted us. We went out and did a site visit in the freezing cold, where we see this picture was taken. This is in the middle of winter. There's some white specks you can see in the picture. It was actually snowing that day. There's ice on the creek here. Then we come back in the summer when it's 1,000,000 degrees with 1,000,000% humidity and start to build this thing. And what the contractor did is they took and they pulled out all the slough material and they set it aside in a little staging area to let it dry out. After they pulled this material out, it became real evident that there was some seeps, some groundwater seeps poking through. And so we combined this with another product that Bill's team sells, American Wick Drain, to be able to capture those seeps and then bring them out of the slope down at the toe of the slope in a controlled fashion, rather than allow them to continue to saturate the embankment itself. So once that was all pulled out together, we placed those drains in there, recompacted the slope. You can see here where all right, I think I'm moving around
now.
Controlling Bill's screen. So this is pretty cool how the Scourlok units are laid out in these cells, and they kind of form the serpent pattern here. It's the way the Scourlok is constructed. It has a certain amount of give associated with it. The way it comes out of the box, it can attain a very wide variety of alignments. But if you need to provide a tighter bend than what it will provide immediately, then you can just modify the basket simply by cutting the different cages and modifying them. It's very, very easy to do that. You can turn it 90 degrees. You can turn it whatever angle you need to attain whatever alignment you need. Now, these wall systems are built segmentally, so they're very, settlement tolerant. If you get settlement in one area, it's not going to really drag itself across to the next cell. Makes it really easy to construct. And then situations like this where we are real rural, we're working in a stream bank, we want something that's going to be, able to tolerate any kind of differential settlement that we might have, even though the contractor is doing their best to make sure things are compact and no settlement will occur at all.
Ben, can I interject and while you get a drink of water? First off, I want to tell everybody that Ben used to live in Tennessee, and he thinks it was cold when he came up here to take those pictures in the winter, and he thinks it was hot and humid when he came back. Just wait. Now he lives further south. It's going to be even harder to get him up here in the cold weather. But one of the things we're blessed with in partnering with Solmax, they're global, but we are in the US. And on my earlier map, I showed we're in 12 states. We get all kinds of weather, all kinds of soil conditions, all kinds of concerns. And in any market, you'll have decision makers, whether it be a city, a DOT, or whatever, say, yeah, but has it ever been proven to work in our weather or in our climate or with our soils? And the answer is yes. This is not some fly-by-night company. This is a global powerhouse, and you see why we partner with them. They could take on the toughest of projects. And the one more thing I'll interject, I asked Ben to include other energies, not just solar, because this is a big push for our infrastructure. Is where is the money being spent for projects that are going to benefit our society long term going into the future? And you don't think of plastics, or you don't think of pipelines, or you don't think of certain things being part of sustainability. But I can tell you our lifestyles and our livelihoods are not going to change so much that we're not going to depend on energy anymore. They're becoming more and more dependent on energy of all kinds. So we at Quick Supply, ASP, Bowman, and Cascade are working real hard to help our partners solve problems on their projects. And a lot of the projects right now are energy related. So this all connects. And thank you, Ben.
No, thank you very much. Yeah, we're still going to need energy, just different forms of it, and getting it transported, from where it's made to the end user is going to still have the same challenges that we have today with the energy sources that we have. So, all right. Bill, I don't know if you want to chime in a little bit about some of these products that were applied to the material. I mentioned that vegetation establishment is pretty important in these areas, and we talked about how vegetation was established at the chemical facility by the use of installation of topsoil and seed and a straw blanket. We utilized a couple different products that ASP furnishes as well to establish vegetation here. The one you see here is a product by Profile called Proganics.
Yep. And one of the most important things that we do is a soil test. So Profile is excellent at asking and expecting a soil test on projects that are supposed to be vegetated, and it can't be overlooked, right? You got to have soil, you got to have water, you got to have air. So the proper selection is key, and some of the soil needs some help. So even though in the Midwest we're blessed with wonderful soil, if you've dug up a pipeline, or if you've had some major catastrophic erosion, or there's been some other construction activity, you probably no longer have the topsoil in that top profile of the organic material. So we need to add that. We can supplement it. So first we feed the soil, and second we do the proper top dressing, whether that's a hydro mulch like Flexterra, which is awesome, or if it's a rolled product on top of the heavy duty TRM down below. We can do it all. We've got a lot of options. Thanks for teeing that up for me.
Sure, yeah. And then
there you go. That's the goal.
All right. So then they have another product that they sprayed on top of that called Flexterra. Not sure if you'd like to add any more on that, Bill.
No, that's exactly what I'm talking about. I mean, some sites are a little harder to access. You see there's some rolled product on some of this erosion control blanket, but when we get these very large scale projects that are hard to access, or for the sake of time, we really push those hydro mulch products, and you can shoot this from 2 or 3 different angles and locations, and make sure there's no shadowing, and that we don't have with a blown and sprayed product, we don't have any tenting. So the Profile says spray it, don't lay it. We obviously have both options available, but yeah, I'm glad you teed that up for me.
This was what it looks like 2 years after construction. We've got good healthy stand of vegetation along the slope. And we've got vegetation starting to take root along the Scourlok itself and holding the embankment together, keeping it out of the creek. This concept has been utilized, I think, 6 times now after this location along the same pipeline to shore up any kind of slopes that it crosses and stream banks to keep those waters protected. This is another location that's actually different than the one I showed you earlier. This is what we want to see. We want to see vegetation in place. It's really starting to take root really well down with the Scourlok down there at the bottom. And here's a shot of that from ground level. We can see overall, we're pretty impressed with this system here. And I think that is bringing us closer to the end. There you go.
It does. That was your last picture, your last slide. I added this for you too. I wanted to get the sunset back in there. I'll take over control just for a moment. I want to go back up and not end it yet, but some of these are really hard to get to later, so the after pictures are tough. So thank you to Ben and ASP's own Ed Nelson, I believe, for getting out there and taking pictures. We love after pictures. So my ask for everybody on this webinar, and we saw a lot of people on here, is if you're involved with one of our projects, please send us after pictures, even if we didn't ask for them. It tells a story. We're always looking for case studies. One of the things we do as your trusted site solutions supplier is we only bring solutions to you that we think are going to be sustainable. And that's not a buzzword just to cheat and use it. That means long-term, you don't have to go back out there and keep replacing or repairing the site. This site right here, I think Ben will tell you, it's not one that's easy to get to all that often. And a lot of these are have controlled access. You have to get permission. So let's just do it right the first time and move on to other projects, right? That's part of our goal. You're going to see this end slide I'm going to get to, but thank you, Ben, for these. I love it. The pictures tell the story. This is the goal. If we can't get vegetation, then we come up with those other solutions that are going to be unvegetated. I'm going to check the Q&A. There's 6 of them in there. I may not get them all time to get them all done within our 1 hour. And the data on the breakdown rate of the microplastics and Pyramat, Matthew Murphy will send you that after the fact. I will tell you one thing from our company we take very seriously is being part of a solution, not part of a problem. If you were part of our geosynthetics webinar a year ago, Melissa Hurley and I addressed that. And there is a difference. And I even wrote it in our newsletter. You should look for our newsletter. I wrote an article, short article about it a month or 2 ago. And I talked about not all plastics are created equal. And we're not going to absolutely get rid of all of them. We have to keep the ones that are functional and doing very good work that are not part of the problem. And there's a lot of work being done in that industry, I promise you, for the big suppliers who are responsible, very good stewards of the land, like Solmax. They take their job and they take their responsibility to the environment very seriously. So they're doing it right. So guess what? Specifications, Matthew. So I'll have Ben and I'll send you the links to that more research on the breakdown of the plastic. But let me tell you right now, we have to partner with people who are doing things the right way. I said at the beginning of this webinar, to whom much is given, much is expected. And you know I didn't make that up. I take the environment very seriously. I'm a father of 3 and soon to be a grandfather of 2. Michael Sharp, I've known you a long time, buddy. What type of product do you recommend for drainage channels that are very sandy, loose gravel, aggregate soils, prone to constant shifting movements, susceptible to landslides? Armormax, man. I'll tell you, we've got some levee projects I can't go into detail about, and our friends at Propex, now Solmax, have helped us with those, and Ben's been involved with them. We could take on the toughest of conditions. And Ben, do you want to add anything to that? Michael's question.
No, I second what you said right there.
Okay.
We have an Armormax solution for that. And then if it's
look for
you consider Scourlok, we can do that too.
And I've known Michael real well, so he can reach out to us, especially if he has some challenging sites where you have a hard time with vegetation. We can help with some of our solutions that might increase your chances of getting vegetation. But if that's just not on the scope of possibilities, then we'll help you with that too. We're not scared of any project. We'll give you what we think would be the best answer and what we would do if we owned it. Jumping the gun, price list. Larry Lee, yes, the price list is available from your local ASP, Quick Supply, Bowman Construction Supply, and Cascade Geo rep. Each rep at each market knows their market, and it's not a cop out. I'm the engineer. they can give you that answer today. So reach out to me, let me know where you're at, Larry, send me a message, bmurphy@aspent.com, and we'll get you in touch with your local sales rep. And maybe I'll write that down and I'll do it after this. Leon Brown, another regular attendee. Scourlok wall, what was that aggregate subdrainage behind the wall in slide 91? American wick drain, we can help you with that. Do you treat it like a segmental wall with under drainage? And Ben, I'll let you answer that on the drainage behind and under a Scourlok wall.
Yes, sometimes we do have to have drainage and sometimes we don't. It depends upon what the soil conditions are, what we're filling it with. And some cases, you saw some stone in that picture. There was a certain amount of that Scourlok wall that was built with stone to be able to provide medium for the drainage water to drain from the back to the front and not create that hydrostatic pressure behind the wall. So we don't have to, a French drain or a drainage system behind a retaining wall is generally incorporating stone and geotextile and pipe. This, we can fill our geotextile line Scourlok with stone. We don't need the pipe. We can just run it right through the face of the wall. So it eliminates a whole nother step.
Perfect. And Ben, as always, thank you, man. You're a champion. I appreciate you. There we are at the end of time. Again, folks, thank you very much. Ben, take care, buddy. Happy 20th anniversary. I appreciate you. Take care.
Thank you. Thanks to all of our attendees. Thank you very much.
All right. See you, Ben. Thanks.